Hi guys, welcome to our multiple transformations video. In this video, we are going to learn how to write functions given multiple transformations and how to graph functions that are involving multiple transformations. So that means we might have a reflection stretch and a translation, or we might have a reflection and a translation. Basically, we're putting some of these together and not just doing reflection stretches and shrinks separately from the translations. So the first thing we're going to do is write functions involving multiple transformations from a verbal description. So letter A says a reflection across the x-axis and a translation write units. Write 7 units. So we're going to write a function that looks like this, but we only need to fill in the parameters when we actually have one of those things happening. So a reflection across the x-axis, we know makes our A value negative. Then a translation write 7 units tells us what our H value is. That would be 7. So all I have in this description is an A and an H. A and H. So when I don't have the other letters, I do not have to include them in the function that we write. So what we're going to write is g of x equals. Now our A value, because the only thing I've done is make it negative, it's going to be -1 because I'm not stretching or shrinking. So you really can just put a negative out front and that will do the reflection. Then we put our parentheses. Because we are not given a horizontal stretch or shrink, our B value is 1 and we don't need to write that. So we can move on to the x minus h. We've moved right 7, so remember that would be the opposite of what we think. That's going to be x minus 7. Close your parentheses and put the squared on there. And because we didn't move up or down, we don't have to put a k. And there is our function. Letter B says a vertical shrink by a factor of 1/4 and a translation left 1 unit and up 3 units. So we have 3 things happening here. First of all, we have a vertical shrink by a factor of 1/4. That gives us an A value of 1/4. The translation left 1 unit gives us an H value of -1, and then up 3 units gives us a K value of +3. So plugging this into our general equation up top, g of x equals our A value, which is 1/4, parentheses, B, but because we're not given a B, we don't have to write that. It's just going to be 1. So then we do x minus h, which would change to x plus 1. Close your parentheses, put your squared, and then plus k. So +3. All right. Letter C, a horizontal shrink by a factor of 1/5. Translation left 2 units and down 6 units. So remember that a horizontal shrink helps us find our B, but we always have to flip that shrink factor to get our actual B value, which would be 5. Then we have left 2 units, which gives us our H value of -2, and down 6 gives us our K value of -6. Okay, now we're going to plug these into our function g of x equals, since we were not given a vertical stretch or shrink, the A value is just 1 and we do not have to write that. But we do have a B value of 5, and right after the 5 we have to put another set of parentheses to do our x minus h. Because h is -2, we're going to put x plus 2, close both parentheses, put the squared, and then do your -6 for the k at the end. All right, we're going to save letter D for class. We are going to do one example of graphing functions using multiple transformations and save the rest to practice together in class. So, tell the transformations that have been applied to the graph of f of x equals x squared. Then sketch its graph by transforming the points -1, 1, 0, 0, and 1, 1. So those are our original graph points. So I'm going to go ahead and plot the parent function as much as I can fit, right? Here are the 3 points that we actually are transforming. You could plot the 2, 4, and negative 2, 4 if you want to see the original shape. Okay, so that's our parent graph. Let's look at our function and see what we are doing to this graph. The first thing we're doing is we have this 1/2 in here, which is our b value. b equals 1/2. So we always flip the b, so that's going to be 2. And since it's 2, we have a horizontal stretch by 2. Then I have x plus 5 inside the parentheses. So x plus 5 helps me know that that's going to move left 5. That's my h value, and the h value is going to be negative 5. So we're moving left 5. And then the plus 2 at the end is our k value, positive 2. So we are moving up 2. Now, when transformations are being applied to a function, they do follow the order of operations. So multiplication comes before addition and subtraction. That means that your reflections and stretches and shrinks come before any translation. So the order that we do transformations is always R, S, T for reflect, and then stretch or shrink, and then translate. So I don't have any reflection going on, so I can skip over that, but I do have a horizontal stretch by 2. So if I were going to stretch this graph horizontally by 2, of course my vertex would still stay where it is, but instead of going right 1, up 1, and left 1, up 1, that horizontal distance is going to be increased by 2. So right 2, up 1, left 2, up 1. So that's after the stretch. Then the translations, I can do these at the same time. I'm going to move left 5 up 2 at each of these points. So the vertex, because it's still at 0, 0, the negative 5, 2 is actually where our h and k values are. That still gives us our vertex. So from 0, 0, I move left 5 up 2, and here I am. Okay. Then you can either count from these points, left 5 up 2, or just know that they are 2 away horizontally from the vertex and 1 away vertically. So right 2, up 1, left 2, up 1. So we have horizontally stretched and we have translated. And there, that's not very good looking, but that's what happened. So this is our graph that has undergone those transformations. And we're going to do some more in class and work together on those. All right, guys, I hope you have a great day, and I'll see you tomorrow.